Hi, my name is Alex Leeuw. I'm in 7207, Probability and Statistics for Business Applications, and today I'll be presenting how review attributes influence product ratings on Amazon. Now first, let me give an overview of what I'll be presenting. First, I'll give some background on my investigation and why it's important to look at. Next, I'll give an overview of the data set. Then I'll explain how I analyze the data. Then I'll show the conditional distributions that I chose to look at. Then I'll explain the model that I chose and why it fits or doesn't fit. And finally, I'll leave some concluding remarks. So first of all, why do online ratings matter? Online reviews influence customer decisions and sales, and it's proven that higher ratings lead to higher visibility and sales volume. Higher ratings also boost a brand's reputation and builds credibility. Overall, higher ratings can make or break a business. Now, in this project, the goal is to investigate how specific attributes of online product reviews affect the likelihood of receiving a positive rating on Amazon. Now let's look at some cited studies. First, Mundami and Schuf in 2010 found that longer reviews are more hopeful. In my investigation, I want to see if I can find some data or come to a conclusion that either supports that or refutes that. In addition, in 2008, Foreman, Gose, and Weisenfeld found that credibility cues make reviews more helpful. Now, credibility cues can take many different forms, but in this study, they'll take the form of helpful votes. Next, let me give an overview of the data set. So, data was collected weekly from Amazon.com using a Java-based web crawler, and this was between February 1st and July 11th in 2012. The dataset includes over 40,000 consumer reviews for more than 2,000 different tablet products, and the dataset contains both structured and unstructured information. Structured information can be easily broken down and categorized in a table. So for example, some examples of this are a binary rating, or an ordinal rating from 1 to 5, the length of review, which is just a number, and whether a review is verified or not. Now, unstructured information is something like review text, which cannot be easily broken down or categorized. This dataset consists of 4 different tables, all of which were used in this investigation. The tables are product characteristics, reviews, market dynamics, and reviewer information. Now, the main variable of interest in this investigation is the customer rating, and this ranges from 1 to 5 stars. Now, I transformed this into a binary variable in order to distinguish between positive and negative reviews. I classified positive reviews as 4 or 5 stars and negative reviews as 1 to 3 stars. As you'll see later in this investigation, this allowed me to use a Bernoulli model and break this down into just a positive or negative, break it down to the reviews into just positive or negative. The goal of this is to predict the likelihood of a review being positive based on specific attributes. Now, the key predictors that I want to look at are whether a purchase is verified by Amazon or not, the length of the review, and the number of helpful votes that the review gets. Next, it's important to note some limitations to the dataset. First of all, ratings are subjective. One consumer's 5-star rating may be very different from another, and the same goes for 1-star ratings. Next, inconsistent standards can cause variation within the same product, meaning that one customer may receive the same product but of a very different quality and would therefore leave a very different review. Next, fake reviews will likely skew our perception of consumer opinions, and the worst part about that is it's really hard to filter out fake reviews. I did so later in the study, but it's hard to find a consistent and reliable method to do so. It's also important to look at the data collection strategy. Now, initially, I thought that the 24-week collection window was pretty short and wouldn't be enough to get the full picture of a product's review. However, most product reviews and consumer sentiment are realized within the first few weeks of a product being released, so the 24-week collection window would be sufficient. Now, it's important to note that this may not be sufficient for long-term trends, but given that most of product reviews that are realized later are probably outliers, this is not an issue in this investigation. Next, let's get into the data analysis. So first, there are 5 key variables in this investigation: rating and binary rating, as previously mentioned; verified purchase, which is simply whether Amazon has verified a purchase or not; review length, which is the number of characters in a review, constructed by counting the number of characters, and helpful votes, which is the number of votes that consider a review to be helpful. Let's look at the summary statistics. For review length, the minimum was 6 characters, median was 560 characters, and the maximum was 31,600 characters. Now this is a wide range, but it makes sense as anybody could leave a review of any length. For helpful votes, the minimum was 6 votes, median was 28, and the maximum was 23,300 votes. This is also a very wide range, but it makes sense since more popular products receive a lot more attention and a lot more people leaving reviews, looking at those reviews, and rating them as helpful or not. For the variables on the right side of the screen, I did not include a lot of the additional summary statistics as they were either not applicable or irrelevant to the nature of the variable. For example, for an ordinal rating of 1 to 5, the minimum will be 1 and the maximum will be 5. But the average was 3.798, and when transformed into a binary rating, it was 0.6826. For verified purchase, the number of unverified purchases was 13,500. The number of verified purchases was 27,260. I also want to mention how I handled the missing data in this investigation. Rows with any values that were missing in the previously mentioned variables were removed in order to simplify our investigation and look at more relevant points of data. Next, let's look at the conditional distributions. First, binary rating by review length. The question that we're looking to answer here is, are long reviews more positive? The null hypothesis is that review length and positivity are independent, and the alternative hypothesis is that they are dependent. When we ran a chi-square test of independence, we see that the p-value is extremely small, and thus we can reject the null hypothesis. This means that there is strong evidence review length indicates positivity. Now let's look at binary rating by helpfulness. Here we're trying to answer whether helpful reviews get better ratings. The null hypothesis is that review helpfulness and positivity are independent, and the alternative hypothesis is that they're dependent. Again, we ran a chi-square test of independence. We get a very, very small p-value, and this also indicates that the helpful reviews are much more likely to be positive. The third conditional distribution is binary rating by verified purchase. Here we're looking at whether verified purchases are more positive. So the null hypothesis is that verified purchase status and positivity are independent, and the alternative hypothesis is that they are dependent. Again, we run a chi-square test of independence. We get a very small p-value, and thus we can conclude that verified purchasers are much more likely to leave positive reviews. Here are the 3 graphs grouped together for a summary. The biggest takeaways from this is that there are a lot more positive reviews than there are negative. This is interesting because positive reviews, 4 and 5 stars, only make up 2 out of the 5 possible ratings. The other one's 1, 2, 3. So if 2 out of the 5 are making up the majority, I think it's worth investigating. It's also interesting to look at how helpful reviews tend to be a lot more positive than less helpful ones, and how verified purchases are much more likely to receive positive ratings, as we saw in the chi-square test of independence. I think that the biggest takeaway from these conditional distributions is that the combination of being verified, long, and helpful strongly indicates that a review will be positive. Next, let's get into the model analysis. So I chose a Bernoulli model. I chose this because they're typically very simple and easy to interpret, and they're useful for modeling when given clear success-failure scenarios, which I did by transforming the rating from an ordinal 1 to 5 to binary 0 or 1. Now, it fulfills the primary assumption of the Bernoulli model, which is that each trial results in either a success or a failure, but it either partially fulfills or does not fulfill the next two, each trial has a fixed probability of success, and there's independence between trials. The limitations to the Bernoulli model is that it oversimplifies the 5-star scale into only 2 variables. We lose nuance between each rating individually because, for example, a rating of 1 is considered the same as a rating of 3. And in the real world, those are very, very different ratings. People that leave 3-star reviews are typically right in the middle versus people who leave 1-star reviews often hate the product. And we lose a lot of information by grouping those together. We also assume independence between the trials, between ratings, but in reality, early reviews influence later reviews. We know this because people look at reviews and typically they're influenced by them. Last, it doesn't account for the fact that there are a lot of factors that play a role in whether or not someone's going to leave a positive rating, and therefore there is not a fixed probability of success or failure for each trial. The alternative model that I propose for this would be an ordinal model. Now, this would allow us to look at each rating individually, all 1 to 5, and analyze each of them similar to how we're analyzing positive versus negative, except that we're getting that information that we're losing by grouping the ratings together. We would have a much better understanding of each rating on its own. Now let's look at how our Bernoulli model predicts the probability of a review being positive. In this graph, we can see that all of the probabilities are concentrated in this range here between around 0.65 to around 0.75, with a very sharp spike around 0.275. There aren't many predictions that are below or above this range, which indicates that the model is conservative and avoids extreme probabilities. I think a big takeaway from this is that it matches the real world skew, that the majority of reviews are positive, and given that, I think it accurately represents the data to the best ability that a Bernoulli model could. Now let's look at how this aligns with the existing research that we looked at the beginning. So again, Mundabi and Schuf in 2010 claimed that longer reviews are more helpful. Now we didn't necessarily look at if longer reviews are more helpful, but we see that longer reviews are more likely to be positive, and so are more helpful reviews. So I think it's interesting, given this finding, given our findings. Foreman, Ghost, and Weisenfeld in 2008 found that credibility cues make reviews more helpful. Once again, we didn't see how credibility cues, in our case, helpful votes played a role in helpfulness, but we did see that those cues increased the chance of a review being positive. And similar to this first finding, there is a correlation, and I'm glad we investigated it. Last, let's get into our final analysis and the biggest takeaways from this investigation. So first, we saw that the attributes that we investigated, the variables, strongly indicate positivity. So verified purchases, longer reviews, and helpful votes strongly increase the likelihood of a review being positive, which means having 4 or 5 stars. We also see that the binary model does give us a good starting point for our investigation, but there's a lot that we lose, a lot of information lost, and there is definitely a much better model to reflect this data. Last, real-world reviews are very complex and nuanced, and it's hard to find a traditional model to match that. With that being said, the Bernoulli model, again, gives us a good starting point, but there are so many different factors at play here that it's hard to find a right model that would properly reflect this data. Thank you for your time, and thank you for listening. After this, I do have my works cited. Thank you.